Okay, we'll go on to question 3. So the first part A, is find the integral of 4 secant squared of 2x dx. Well, just using your formula sheet, secant squared is the derivative of tangent x. So this will be 4 tangent of 2x, but then the reverse chain rule, you have to divide by the derivative of the inside, so divided by 2 and then plus c. So that's just 2 tan of 2x plus c. Okay, part B. In Gloucestershire, in the United Kingdom, there's an annual competition for people running down a hill, chasing a cheese wheel. The acceleration for one of these blocks of cheese can be modeled by this function. So the acceleration is equal to 0.05 plus 0.04 t. How far will the block of cheese travel in the 25 seconds needed to take to complete the race? So you want the distance. So what is s of 25 equal to? Well, I mean, so you got to integrate twice, from acceleration to velocity and then velocity to distance. So integrating this gives you 0.05 t, then plus 0.04 t squared over 2, and that over 2 you can just simplify as that, and then you have a plus c. And you kind of assume that the cheese starts at a velocity of 0 because you push it down. So at v of 0, it also equals 0. So therefore c is equal to 0. So v of t is equal to 0.05 t plus 0.02 t squared. And you integrate this again to get s of t is 0.05 t squared over 2 plus 0.02 t cubed over 3 plus c. And again, you assume that when it starts, the displacement is 0, so therefore c is equal to 0. So the displacement is 0.05 t squared over 2 plus 0.02 t cubed over 3. And then you just substitute in t is equal to 25. So s of 25 is equal to 0.05 times 25 squared over 2 plus 0.02 times 25 cubed over 3, which gives you, so 0.05 times 25 squared over 2 plus 0.02 times 25 cubed divided by 3 gives you 119.79, and it's in meters. Okay. On to part C. So find the value of k such that, so the integral that you have here is from 6 to k of root 2x minus 3 dx is equal to 63. So to integrate this, you're going to use the reverse chain rule. So first, rewrite this as 2x minus 3 to the power of 1/2 dx is equal to 63. Integrating this, you raise the power by 1, so 3/2, divided by the new power. And then you also have to divide it by the derivative of the inside function. So that's dividing it by 2 as well. From 6 to k is equal to 63. So then you can simplify this a little bit. So you have here 3/2. 3/2 times 2. The 2's cancel each other out. So then it's just 2x minus 3 to the power of 3/2 over 3. 6 to k is equal to 63. So then you let x equals k. So the first part is going to be 2k minus 3 to the power of 3/2 over 3 minus 2 times 6 is 12 minus 3, that's 9. So 9 to the power of 3/2 over 3 gives you 63. Let's see, 9 to the power of 3/2 and then divide that by 3 gives you just 9. A. Oh, okay, yeah, sure. Equals 9. So this part is equal to 9. So because it's just equal to 9, so it's minus 9. You can bring the minus 9 to the other side to be plus 9. So 63 plus 9 is 72. So now you have here 2k minus 3 to the power of 3/2. Oh, let's just write it out. Minus 9, so over 3 is equal to 63. You can bring the 9 to the other side to be plus 9. And then after you do that, you can then multiply both sides by 3 to get rid of the 3 over here. So what you have now, you have 2k minus 3, so 3 over 2, is equal to 72 times 3. It's going to be 216. And then in order to get rid of the to the power 3 over 2, you're just going to raise to the power on both sides 2 over 3. So then they cancel each other out. So 216 to the power of 2 over 3. It's going to give you 36. So then 2k minus 3 is equal to 36. So then solving for k, it's going to be 39 over 2. 19.5. And that's it. Okay. Okay, on to the last page, part D. Oops. So calculate the integral from 0 to 4 of tan of pi x over 10 dx. And they said you might find the identity tan of a is equal to sine a over cosine a. So you can rewrite this as 0 to 4 of sine of pi x over 10 over cosine pi x over 10. So you notice here that the cosine derives into sine. So you're going to use the identity that the integral of f prime over f is going to be ln of f. So you use that identity. But bear in mind, you also have to use the reverse chain rule. So you have to divide by the derivative of the inside as well. But we'll see that. So here, we can use a u substitution as well. So if you let u equals to cosine of pi x over 10, then du is equal to negative sine pi x over 10, and then dx. So then dx rearranges to du over negative sine of pi x over 10. Oh, so I have to multiply this by the derivative of the inside as well, so which is pi over 10. This is multiplied by pi over 10 as well. So then you can bring this to the integral. So the integral is equal to the integral from 0 to 4. And you technically should be changing the limits of integration here, but they're kind of irrelevant for now. So this is sine of pi x over 10 over cosine, which is then substitute with u, and then dx has been substituted by du over negative pi over 10 sine of pi x over 10. So then the signs, they cancel each other out. And then this is negative, but it's a constant, so you can bring the constant to the front of the integral. So it is negative 10 over pi, because it's 1 divided by pi over 10, so it's a reciprocal of pi over 10, which is just 10 over pi, and it's negative. And the integral from 1 over u du. So this becomes negative 10 over pi ln of u plus c. And what was u? Well, actually, we don't want plus c because we want it to be a definite integral from 0 to 4. But what was u? Well, this is negative 10 over pi. U was ln, so u was cosine of pi x over 10. And the limits of integration are from 0 to 4. So this is negative 10 pi multiplied by, well, when x is equal to 4, this is ln of cosine of 4 pi over 10 reduces down to 2 pi over 5. And then minus ln of cosine, well, when x is equal to 0, all that becomes 0. So cosine of 0 just becomes 1. And then cosine of 2 pi over 5 is a number of some sort. And we take the natural log of that. Okay, and then we minus 1 from that. Okay, and then we multiply it by negative 10 over pi. And we get approximately 6.921. Hopefully that is right. Okay, on to part E. Oh my days. So part E, the graph of the function y equals 4 sine squared x over k minus 1 over sine squared x over k. Okay, and the function has roots of x equals k over 6 and x equals 5k pi over 6. Determine the area of the section in the graph shown in terms of k. Okay, that is an interesting one. Okay, so I'm trying to figure out a way to integrate this function. And I'm trying to look for relationships here. I can see that I might be able to do no, I probably can't do a substitution. I might need to use some rules here. I can technically separate this out into 4 sine squared of x over k over sine squared of x over k, and then minus 1 over sine squared of x over k. And then this gives me 4 minus 1 over sine squared of x over k, which is possible. I guess I could write that as 4 minus, well, 1 over sine is cosecant, so I can write this as negative cosecant squared of x minus k. But the question is there an identity or a derivative here of cosecant squared? And for that, I'll need to search up the formula sheet. So, NCA level 3, calculus formula sheet. Oh, I went way past it. Okay, so negative cosecant squared x is the derivative of cotangent x. So I can just replace this with, okay, so this is good. So the area is equal to the integral from the first root, which is k pi over 6, to the second root of 5k pi over 6. And this is of 4 minus cosecant squared of x over k dx. And this is great because 4 just integrates to 4x, and the cosec squared we have now discovered integrates to cotangent, and it's positive cotangent as well. Positive cotangent of x over k. But then using the reverse chain rule, you have to divide it by the derivative of the inside function as well, which is over 1 over k from k pi over 6 to 5k pi over 6. And you can see here that if you're dividing by a fraction, then let's take the reciprocal of that. So this becomes just k. So this is 4x plus k cotangent of x over k from k pi over 6, and then 5k pi over 6. So then substituting in x equals 5k pi over 6 and then k pi over 6, this gives us 4 times 5k pi over 6 plus k times cotangent of 5k pi over 6, and then divided by k. That's the first part, and then minus 4 times k pi over 6, and then plus k times cotangent of k pi over 6, and then over k. So then expanding all this, so the 4 and the 6 cancel each other out to 2 over 3. 2 times 5 is 10, so that'll be 10 k pi over 3. And then over here you've got k taking out the k over there, so it's just k cotangent of 5 pi over 6 minus Again, the 4 and the 6 cancel each other out to 2 over 3. So this is 2k pi over 3 plus k times cotangent of, again, the k's cancel each other out here, so that's just pi over 6. And cotangent, recall, is 1 over 10. So then this area is equal to, what was it? 10k pi over 3 plus k over tangent of 5 pi over 6. That's the first part. And then minus the second part, which was the 2k pi over 3 plus k over tangent of pi over 6. Okay, so then we just need to calculate all these values here. So you can see that the 10k pi over 3 and the 2k pi over 3, they are like terms. That becomes 10 minus 2, which is 8k pi over 3. And then the tan of 5 pi over 6 is equal to negative root 3 over 3. And then tan of pi over 6 is positive root 3 over 3. So this is plus k over negative root 3 over 3. And then this minus here, well, it influenced this positive here, and then this turns into minus as well. So this becomes minus k over positive root 3 over 3. So you can see here that there's two lots of negatives here. This negative over here can be brought up to there. So it's negative k over root 3 over 3, and then minus k over root 3 over 3. And again, you can kind of imagine this as, well, if we just take this section as k over root 3 over 3, that is the same as k divided by root 3 over 3, which can be rewritten as k times 3 over root 3. So this is 3k over root 3. And it's negative, so it's just going to be negative. And then this one's also negative, and they're both the same, so there's two lots of them. So if there's two lots of this thing over here, it's just going to be negative 6k. So 8k pi over 3 minus 6k over root 3. And then this over here, we can kind of join together as we can rationalize this denominator, and we can make it the same denominators to multiply together, to subtract together. So this is 8k pi minus 6 root 3k over 3. And I think that is it. That is the area. You can factorize out the k in here. So then you can factorize out the 2 as well. So 2k bracket 4 pi minus 3 root 3 over 3. So that is the area dependent on k. So yeah, those are my answers for this exam. I would say that was quite difficult, and of course I don't know if I'm right or not. But yeah, I hope this helps, kind of. Any questions, just ask me. Other than that, I will finish off. Okay, thank you. Bye.